Welcome back. So this is what we're doing. So I'm gonna give you 7 minutes to work on the warm up, and then we'll come back and do them together. There we go. There we go. So now this is what we're doing. So for the first one, about like that. So this is what we're gonna do. So we have that this is equal to, and now I want to distribute the x. So we have that x times x is x squared. Then you have that x times m is equal to mx, right? There we go. And now I will do the same thing for the second one. So then you have m times x, which is going to be equal to mx, and then you have that m times n is going to be equal to m squared. So now that we multiply everything out, so now we just got to combine like terms, right? So then this be equal to, we will have that this is x squared plus mx plus mx is 2 mx, and then plus m squared. And then that's all you gotta do for it. Now, for the next one, we'll pretty much be doing the same process. So the first thing I want to do, I want to distribute the x. So x times x is equal to x squared. And then you have that x times negative n is going to be equal to negative nx. And then I'll do the same thing for the other ones. Then I have that negative n times x is going to be equal to negative mx. And then negative n times n. Remember that negative times a negative is going to be a positive. So this would be plus m times n. And that's all we have to do for now. Now, for the next two, and then I'm going to put it out so somebody can look at it. I'll do the same process. So the first thing you always want to do, you want to distribute the x to each term on your second binomial. So let's see. So now I have that this will be equal to, and then you have x times x, which should be x squared. Then you have x times negative m, which would be minus mx. Then we have m times x, which would be mx. And then for your last one, you have n times negative n. Again, a positive times a negative is a negative, so that should be minus. And then m times n is m squared. There you go. So now, I want to combine like terms, right? Let's get that out. So now we have x squared, negative mx plus mx at 0, so that cancels out, and then you're left with negative m squared. And that's what it is. So now for your next one, again, we'll do it again kind of like the same process. So first, this will be equal to, and then I want to see the x times x is going to be x squared. X times negative m is going to be negative, let me fix that. This will be negative nx, and then you have that m times x will be plus mx, and then for your last one we have that m times negative n. A positive times a negative will be negative, and then this will be m. And that'll be all. Now, assume that we have this graph, right? Let me zoom out a little bit. Yeah, so assume we have this graph, right? So this is a rocket. It's being launched, right? Now notice how this rocket is being launched from 100 feet off the ground, right? So now your initial height is going to be 100. Now, another thing that we can see from this graph is that the rocket was 7 minutes in the air, right? So 7 minutes in the air, right? So it took 7 seconds for the rocket after it was launched to hit the ground. And it's like two kind of like easy points. Another one that's not so hard to see, that's a little hard to see, will be this point up here. So now, at this point, you know that that was when the rocket reaches maximum height. So now, another interesting point that I would like to find out will be what's the x value for this point, and what's your y value for this point. So, moving forward, there are some key features of the graph that we'll be looking at. So let's see. Do we have names for these specific points? So now this one we know, because for this one, your x value is 0, and you have a y value. So that we call a y-intercept, right? You have, but then your y value is 0, so that is your x-intercept. But then also we have a new point that we don't know what it's called, so let's see. So again, these are your x-intercepts. This is your vertex of your graph. So the vertex of the graph, that's where your graph, it changes direction. It either goes from negative to positive, or from positive to negative. So again, that's just where your graph changes directions. So now, that point or that line where your graph changes direction, that is called your axis of symmetry, which is this point. In this case, it will be x equal to 1. That'll be your axis of symmetry. And then we have the all points, which will be your y-intercept. So now, this is what I want you to do. I want you to pause the video, take a few minutes, and I want you to write this down. So first you have the standard form of a quadratic, the factor form, and the vertex form. If a is greater than 0, you know that your graph is going to open upwards, and you're going to have a minimum. If a is less than 0, it's going to open downwards, and you're going to have a maximum. And then this is the equation for your axis of symmetry. So right now, I will give you the axis of symmetry. Moving forward, I'm going to show you how we come up with that. So then again, just pause the video and go ahead and write this down. Now, let me take you back a little bit. Do you remember when we did the linear functions that we have? Well, we have y minus y sub 1 equals n times x minus x sub 1, which this is the point slope formula, right? Which this formula gave you the slope, and then it gave you 2 points on your graph. So any 2 points on your graph, right? Then we have y equals mx plus b. Which was your slope-intercept form, right? Which in this case, it gave you the slope, and it gave you your y-intercept, right? And then we also have, which we didn't talk about it so much because this is kind of this already set up for you. So you had ax plus by equals c. So that's just for your standard form. And think about it when we have an equation and we're just trying to solve for y. That means your equation was given to you in standard form. So all this, it gives you different forms for your graphs, right? So now, if we go back to this one, so you have a times x squared plus bx plus c, right? So now if you look at it, right? When x equals 0, you are left up with this value, which is your y-intercept, right? So now, for the second one, the fractal form, there's something special about these 2 points, which we will talk more about as we move forward. And then for your last one, there's something special about these 2 points here. So each form will give you a little piece of information, a different piece of information about your graph. So for now, we're just going to concentrate on the standard form, and then we'll do the factor form and then the vertex form. So now, let's look at the following function. We have negative x squared plus 4x plus 5, right? So now, this equation was open upwards or downwards. So we want to look at the leading coefficient, which would be negative 1. Because negative 1 is less than 0, we know that this is going to open downwards, right? So now, let's see. This is going to open downwards. Because this is going to open downwards, this is going to have a maximum point. So this will be a maximum. So now, again, how do we find the axis of symmetry? Let's see. Your axis of symmetry, remember, your equation is given by x equals negative v divided by 2a, right? So now, if I look at this, well, let's put that negative in first. Your v value is going to be 4 divided by 2. Your a value is going to be negative 1. So you want to put that in. There we go. So now, well, let's do this one. You have that negative 4 divided by negative 2 is going to be positive 2. So this will be 2. There we go. So now you know that your axis of symmetry is going to be equal to x equals 2. Okay? So now, how do you find the vertex, right? So now you're going to take that point, x equals 2, and you're going to substitute it into your function. So let's go back to this one. So now, my equation is g of x equals negative x squared plus 4x, and let's see, this was plus 5, plus 5. So now, I want to evaluate this function, f of x, g of x, 2, evaluate it at 2, right? So now I have negative, and then 2 squared plus 4x. Oh, no, I'm sorry, that's not 4x. Let's see. So this is 4 times 2 plus 5. There we go. So now, 2 squared is 4. So this will be minus 4 plus 8 plus 5. There we go. So now, you have that negative 4 plus 8 is negative 4. Sorry, it's positive 4. And then positive 4 plus 5 is going to be 9. So now, this point up here, your vertex is going to be 2, 9. So now you're going to go up. And you know that this point up here, it's going to be 2, 9. be all for today. So I'll put some homework from either the workbook or the book, where you have to tell me whether your graph is open and downwards or upwards, if it has a maximum or minimum, and then you're going to tell me the axis of symmetry and the vertex of the graph. And that's it for today, so stay tuned. I'll see you guys later.
Yeah, yeah.